Good evening, Gulib.
Good evening, sir.
Yeah, can you hear me?
Yes, sir. You are audible, sir.
Okay, okay, okay.
Yes.
Uh,
Sir, we have live stream on YouTube.
can you see me also?
Yes, sir. Yes, sir.
Okay, and where will be the recording happen? In your
Live.
laptop or where?
Sir, it will be on cloud, sir. It will be on cloud.
Oh, okay, 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 okay. ठीक है, you continue with your work. I am there online.
Mr. Ghosh, I am audible.
Yes, sir, you are audible.
Okay, okay. Good. Good evening, sir.
Good evening, sir. Good evening.
I am PK Mr. Director General of INSDAG, sir.
Good evening.
Aye.
Yes, sir. Good evening. This is MM Ghosh.
Sir, good evening.
Yes, sir. Your audio and visual both are fine.
Oh, excellent. Thank you.
Right.
Dr. Gupta, namaskar.
Namaste, sir. Namaste.
नमस्कार नमस्कार
नमस्ते डॉक्टर सुब्रमण्यम. नमस्ते मिश्रा साहब. मिश्रा साहब, आपके चेहरे पे रोशनी कम पड़ रही है.
क्या सर रोशनी?
लाइट नहीं आ रही है. वी आर नॉट
अच्छा.
एबल टू सी योर फेस. गुड इवनिंग डॉक्टर घोष. घोष साहब, नमस्ते.
Is it
Yes, sir.
better?
Good evening, sir. Good evening.
Better now, sir?
यस सर.
Actually, it will be much better for me because the sun is in front of me. So,
Oh, correct,
east
sir.
side.
यस सर. You are very well lit.
And it is helping for me.
It must be morning hours there, I believe.
Yeah, 8:30 a.m.
8:30 a.m. Wonderful, sir. Wonderful.
Sir, we will start within 5 minutes.
You'll wait for some more participants, Mr. Ghosh?
No problem.
Yes, sir.
Yes, sir.
The
Yes.
participants are now joining. So let
Okay.
us give 2 or 3, 4 minutes more.
Okay, not an issue. Dr. Premakrishna sir, namaste sir. Namaste sir, namaste.
No, sir. Namaste.
Sir, I think sir you are in mute, sir.
Yes, I am now unmuted.
Sir, namaste sir, namaste.
Namaskar. Congratulations on your foundation day.
Thank you, sir. Thank you. We really need good wishes of veterans like you and Dr. Subramaniam sir. This is a small institute and it has big aspirations. So
And also compliments for getting hold of Dr. Subramaniam for this lecture.
Yes.
Thank you. Thank you, Professor Prem.
You're welcome.
Mr. Kar, good evening, Jain Karji.
Sir, good evening, sir, and good evening to Professor Saab. So we'll be looking forward to hearing Sir Subramaniam sir.
Good.
So and all
Mr.
the
Jain Kar is a GM from SAIL, Steel Authority. And Steel Authority
Welcome, sir.
thank you,
is
sir.
one
Thank you,
of
sir.
our founder members.
Yes, sir.
So, and they have been really watching our activities and helping us to grow.
So we are learning, sir. A lot of learning, sir. So thank you, sir, for giving this opportunity to learn, sir.
Yes, sir. I think let us start.
Correct.
There are more than 100 participants and the participants are joining. So let them also join and we start our program also. So
Perfect.
good evening to all participants, professors, professionals and students. On this date in 1996, 26th of August, INSDAG had its registration and then the actual activity started from 1999. So that is when INSDAG was born. So in the meantime, it was the motto that the consumption part of steel is to be taken care of. And so INSDAG was given a job of how to increase the consumption of steel in the country. So if we recall, the crude steel production at this moment in 2025 is where we are in the position number 2. The consumption also has increased a lot, and the consumption figure is 159.8 million ton in 2025. It was found that there were certain lacunas, or there were certain gaps which could have to be filled in order to increase the consumption of steel. And so INSDAG was given that job with the help of all the major manufacturers and with the background support of Ministry of Steel. INSDAG started its venture. So in order to commemorate this day, for the last 3 years, INSDAG has started a popular lecture series. The first one, 2 years back, was delivered by Dr. CVR Murthy. Last year, it was Dr. Arul Jayachandran, both from IIT Madras. And today, we will have Dr. N. Subramaniam as the speaker. So we start with this. Before that, I would request our Director General, Sri P.K. Mishra, to say a few words of INSDAG. So over to Sri P.K. Mishra.
Good evening again, sir, Dr. Subramanian, sir. And my respectful thanks to Dr. Prem Krishna, sir, Dr. Abhay Gupta, our esteemed Executive Council members,
Thank you,
and
sir.
and Mr. J.N. of SAIL, Mr. Hisikesh of Tata Steel, and all other participants and esteemed participants who have cared to join this lecture series. We believe this is going to be greatly beneficial for all the participants coming from Dr. N. Subramaniam. This lecture coming from Dr. N. Subramaniam. Sir, it's my privilege to welcome you. You have been a long-standing patron, and you have been giving timely advice to us from time to time. For at least I know that it is you who has given us the idea about the journal, which we are going to bring out in next 1 or 2 months' time. It was your suggestion that we acted on. Sir, this organization is now really trying to help the professionals know a little more about steel applications. Two things we have flagged by now. There are a number of reasons why steel consumption is not growing, but two major reasons. The professionals who are coming out from the students who are coming out from the engineering colleges, their exposure to steel application is inadequate. The course content is not there. We have been taking up with the AICT, we have been taking up with the ministry, but that course content, maybe once AICT cares to revise the course content, that may happen. But the students who are coming out of the colleges, they don't know much about steel applications, whereas in the marketplace today, there is a demand for steel application. And there is a gap in knowledge among the professionals about steel usage. That is what this institute is now trying to provide, some kind of online training programs, certificate courses, and some kind of other short-term courses in different institutes, so as to create awareness about the steel application and also provide some insight on important topics. Like tomorrow we'll have it online training program on steel connection, and we have got 150 paid participants, professionals who have shown the interest to learn about this topic. And every month almost we are holding some kind of training program with help of experts and professionals and professors, academicians, for on topics of contemporary interest: steel composite design, steel connection, light gauge steel design, and various codes. So different type of topics we have chosen as per the requirements of the our members and participants. And I suggest, I request all the participants here also to convey to us what kind of topics they would like to be covered in our training calendar. Our training calendar is available on our website. We have made a training calendar which covers 8 to 9 topics for this year. And we have also certificate courses organized with help of ACRC Chennai, this NIT Trichy, IIST Sipur. Our next ACRC certificate course is going to help in support partnership of ACRC Chennai on tower design. That will be held sometime in September. So my request to all the participants, please, this is a not-for-profit organization. We are not doing our programs for money. We are doing our programs only for increasing your knowledge on steel applications so that steel usage is made effectively and proper and durable structures, sustainable structures are made in the country. That is our intention. And please join us. Please participate in our programs. Please suggest what are the topics that we should take up. And you will also get to know many such important names like Dr. Subramaniam. Dr. Ellen Gupta just joined, sir. Sir, namaskar. And Dr. Gupta is helping us to launch that journal, sir. I was just mentioning. And that is your brainchild, Dr. Subramaniam. That is your brainchild. And you have kindly contributed an article also. And Dr. Gupta, has kindly consented to, help us to put this journal in place. Sir, namaskar. Uh, so with these words, I once again warmly welcome Dr. N. Subramaniam. It's a privilege that you have kindly consented for this lecture, and I am sure this is going to be hugely beneficial for the participants who are keen to know about more and more about steel applications in construction. Thank you, sir.
Thank you, sir. In the meantime, I see our ex-DG, Sri Shushim Banerjee, has also joined the program. So welcome, sir. Now, a little bit of Dr. N. Subramaniam. It is the book which we refer to each and every day. He is an author, a consultant, mentor, now lives in USA. A little bit of background. With the doctorate from IIT Madras, he also worked with TU Berlin and the TU Bundeswehr Munich for 2 years as an Alexander von Humboldt Fellow. Little bit of tricky pronunciation. He was the chief executive of Computer Design Consultant Chennai for 26 years. He has 48 years of professional experience in consultancy, research, and teaching in India and abroad. Has designed 800 projects and developed several software packages. Dr. Subramaniam has authored 25 books and over 325 papers. He is a fellow in many professional organizations and served as vice president of the Indian Concrete Institute and the Association of Consulting Civil Engineers India. He is the recipient of several awards and recognitions, which include Fellow of the Indian National Academy of Engineering, the 2024 Edmund Friedman Professional Recognition Award of the American Society of Civil Engineers, Honorary Fellow of the Indian Association of Structural Engineers and ICI, ACCEI Gaurav Award in 2021, ICI L&T Lifetime Achievement Awards, Distinguished Alumnus in the field of Industry and Entrepreneurship Award from College of Engineering, Windy, Anna University, Chennai, ACC Nagadi Award for Best Publication for 3 of his books. He serves as the editorial board review committee of several internal and Indian journals. We would also like to rope into the journal which INSDAG is planning to develop. With this small CV, I would now request Dr. N. Subramaniam to take the stage. Sir, over to you now.
Thank you, Engineer Ghosh,
Yes.
for a nice introduction. First of all, I would like to thank Engineer Ghosh and the Director General, Dr. Mishra, for inviting me to present this Foundation Day lecture. And I also thank all the important persons who have joined to hear me, especially Professor Prem Krishna, Professor Ellen Gupta, and others. I don't see them here. Probably it will be seen by others. So let me first share my presentation. I first of all wish you all a happy Onam and Miladi Nabi. I'm happy that Professor Murthy and Arul Jayachandran from IIT Madras were the previous presenters in the previous Foundation Day lectures. So I am also a product of IIT Madras. I did my PhD from IIT, as Engineer Ghosh told us. 1 minute. Can all of you see this? Hello?
Sir, we are not able to see your presentation, sir.
Okay.
Not yet shared, sir.
Okay.
Is there a sharing right issue?
1 minute, 1 minute.
Siddharth?
1 minute, sir.
Yeah.
Yes, sir, something has come up.
Can I see now?
Yes, sir. It is
Yes,
clear.
yes, we can see your
Okay.
screen.
Okay, thank you, thank you. Of course, when Engineer Ghosh asked me to present a lecture, and I gave this topic, recent developments in steel construction, he asked me to give a subtitle. So I selected so many things, and I thought it will be an easy job for me to present the developments. But when I looked into the literature and other presentations, I found that a number of researchers all over the world have developed so many things. So what I did was, of course, before that, I would like to dedicate this to my friend Dr. Bandyopadhyaya, and also Dr. Pradeep Kumar, current Director General, and my association with INSDAG. I have reviewed two publications, INS 047 and INS 048, and also presented two papers in the two steel sections book published by INSDAG in 2004 and 2008. Okay. These are the out of the so much development, I have selected some 14 topics. I don't know whether I will be able to complete all these topics within the given time, but anyhow, I will try to present them. And some of the things I will go fast so that I could finish it within 1.5 hours. So the topics are 3D printing and wire arc additive manufacturing, hollow steel sections and jumbo hollow steel sections, high strength steel, stainless steel members and bolts, automated welding, curved steel, diagrid systems to resist lateral forces, earthquake resistant pre-qualified moment connections, steel plate shear walls, composite speed core walls, painting systems to reduce corrosion, and repair of steel sections using VAM and cold spray, and sustainability and reuse of steel sections, and finally AA and related topics. So all of you know that steel is primarily produced using one of the two methods, that is blast furnace, basic oxygen furnace, and electric or arc furnace. So in India, 43% is by BF and BOF and 57% by EF. And all of you know that EAF is different from BF or BOF route, as it does not produce iron and solely produces steel. And steel production in EAF involves melting recycled steel scrap using high-powered electric arcs and is more sustainable. Of course, already Ghosh told that India produced about 205 million tons of steel in 2025. So, so we will first take the 3D printing. When printing structural steel members or connections, power-based methods like laser power bed fusion used in low volume, high value parts like machine parts, etc., are rarely used due to chamber size constraints and high cost. Instead, the industry uses wire arc additive manufacturing, WAM, a form of direct energy deposition, laser wire electron beam DED, cold spray additive manufacturing. We will talk about this cold spray additive manufacturing at the end when we are talking about the repair. These techniques function essentially as computer-controlled automated arc welding system that build large solid steel geometries layer by layer. These are the equipments necessary for the 3D printing. So the main is this robotic manipulator or CNC gantry, which is a 6-axis. You see here, 6-axis articulated industrial robotic arm like KUKA or large multi-axis CNC gantry. This controls the path and deposition speed of the welding head. And we need a power source or welding generator, high precision arc welding power source using standard processes like cold metal transfer, etc. A welding torch and wire feeder automatically feeds solid or flux cored steel wire, typically 0.8 mm to 1.6 mm diameter, directly to the heat source at controlled rates. Then we also need a shield gas system. It delivers inert active gas mixtures such as argon around the weld pool to protect hot structural steel from oxidation or nitrating. And there is a build table. I guess this is the build table. Heavy steel base plate anchored to a rotary tilt positioner, allowing multi-directional printing without requiring print supports. Additionally, we need a cam and slicing software that calculates the 3D tooth path to control heat input and to prevent thermal distortion. And finally, thermal monitoring and pyrometers are also necessary. They are infrared cameras or pyrometers measure interpass temperature in real time to prevent thermal buildup and grain coarsening in the steel. So this is an example of the system. So you have a design domain where you design, and then it does the layout, geometry, and optimization. And the optimization results in this type of structure. And from that, design model is prepared. And using slicing model of the computer, we use the 3D printing as I already explained. These are the different parts of the 3D printing system. You know that using traditional rolled sections, precise thickness cannot be used. Actually, sometimes even when you use optimization is not very much used in steel sections because by optimizing you may get a thickness of 2.3 mm or 4.5 mm like that. But you cannot use them because the rolled sections available in India are listed in IS 808. Many of them may not be available in the market. But whereas we are using the 3D printing, we are optimizing and we may get such thicknesses. So that in that way, this will be useful to produce structures with the optimized geometry and also thickness. And I just wanted to show you the world's first 10.5 meter long 3D printed pedestrian bridge at Amsterdam. This bridge was developed by researchers at Imperial College London in collaboration with Dutch company MX3D and Arup. The construction took 4 years using about 4,500 kg of stainless steel. Of course, it took 4 years because this is the first world's printed pedestrian bridge. Of course, every day some research is being conducted and the speed will increase. I just wanted to show the advantages of 3D printing. The advantages are high deposition rates. VAM deposits metal at 1 to 10 kg per hour compared to 0.1 kg per hour for laser powder bed systems, making it economically viable for large structural elements. On material efficiency, it wastes up to ordinary other machines waste up to 80% of steel stock, but 3D printing creates near net shape preforms using only the steel necessary for structural integrity. And topology optimization, as I already explained that using the software it optimizes, and elimination of connection plates. So complex multiplanar connections, for example, tubular space frame nodes can be printed as a single monolithic unit, eliminating failure-prone field welds and heavy gusset plates. Scalability, the build volume is limited only by the reach of the robotic arm or CNC gantry, allowing components spanning several meters. On-demand and remote fabrication. Robotic cells can be deployed inside fabrication shops or near construction sites also to print custom structural repair parts, which I will be explaining at the end, or specialized connectors on demand. And I am comparing it with the traditional rolled steel. So I will not read the traditional rolled steels. I will only read the 3D printed steel parts. So material homogeneity, traditional, of course, isotropic, equal strength in all direction. But the problem here is isotropic, that is layer dependent properties. Cost efficiency, even high deposition rates, as I have shown, 1 to 10 kg per hour, are vastly slower and far more expensive per unit weight than traditional rolling. Cost effective only for high complex geometries right now. And surface finish, it is, of course, it is rough and corrugated, requires machining at bolt connection pads. These surface undulations act as notch stress concentration under cyclic loading. Dimensional tolerance, high thermal distortion requires machining for tight fits. And code compliance, you know that our using traditional rolled steel, we have traditional structural codes which are being revised every 5 years. But here, case to case engineering approval and experimental validation is required. Of course, 3D printing is in the infancy, so probably in a few years it will overcome many of these problems. And next we will go to the hollow steel sections and jumbo hollow steel sections. So why hollow steel sections? As per 16th edition of the AIC Steel Construction Manual, 1,160 different hollow steel sections are available in America. The square HSE hollow HSS range from 12.5 to by 12.5 millimeters to 550 by 550 millimeter. So that's a very big range. So similar ranges are available in rectangular and also circular HSS. In USA, Atlas tube, which makes these tubes with a thickness of up to 25 mm. In India, Tata Structurals are manufacturing it as per IS 4923 and IS 1161. And they are simpler and economical beam and column connections than those in white flange sections. While welding is most common, bolted blind innovative connections including shuriken by Atlas tube and Lidopter's hollow bolt and blind bolt have been developed. I will discuss about the shuriken and hollow bolt in the subsequent slides. They have higher strength to weight ratio in compression compared to white flange sections. And in column application, they can have long unbraced length, utilize less steel than white flange sections to carry the same load, offering cost savings and a reduced embodied carbon. And these sections put materials at the perimeter, hence are very efficient at resisting biaxial bending. Hence used in column and long span applications where lateral torsional buckling is common. and they are ideal for resiliency and accidental rolling. Their symmetry makes it ideal for accidental blast loading, in which the direction of the load is unknown. And we can also fill the gaps with concrete. So these composite columns can be used to increase load capacity and resilience. All of you know that torsional constant is up to 200 times greater for this hollow section than for open section. For situations that induce torsion, including curved members, which I will discuss later, hollow sections is the ideal choice. And they have smaller footprint due to the efficient shape. This allows for more usable floor space area within the building. And less coating. Actually, hollow sections compared to open sections of equal capacity have smaller perimeter and surface area, requiring less material for coating or fireproofing, and hence reducing cost. Additionally, the absence of re-entrant corners in HSS simplifies coating application, enhancing durability through more consistent thickness at the corners. And visual appeal. Actually, architects choose hollow steel sections because of their look when used in exposed structures. Most of the award-winning structures from recent years in the USA all have one thing in common: they use hollow steel sections. So let me show one example of the award-winning hollow steel sections. This is San Diego International Airport Terminal. Actually, it is recognized for its innovative design, effective use of materials, particularly hollow sections, which help to meet seismic requirements while creating expansive open spaces. It has enhanced aesthetic appeal and significant cost savings of $100 million. So I was telling about the shuriken connections by Atlas Tubes. It was developed by Ted Goldstein. He is an inventor, and he is originally from New York and moved into Japan in 2018. And at that time only he developed shuriken. So unlike traditional connections that require dual side access, that is when you are bolting, you need to have access on both sides. But shuriken simplifies installation, making it ideal for tight, restricted or inaccessible areas, while also ensuring faster assembly, lower cost and easier inspection in the field. It is a patented internal connection solution for hollow steel that functions as one-time use wrench, enabling secure bolting from one side only. So let me see. So this is a hollow steel tube, and we have openings, and inside this is this device is welded, tack welded to the metal plate in the fabrication shop. And on site, the second member is simply bolted to the fixed plate using the connection with no need for internal access. So it is enough if you are tightening from the outside. This results in faster assembly, fewer alignment issues, reduced labor and welding costs. So I have already told you some of the advantages: one-sided bolting, cleaner aesthetics, faster construction, cost-effective use, and easy inspections. Another thing developed, of course, this type of bolting is already available in UK and other places. I don't know about India. And this one has a bolt which has a sleeve. So while tightening, the sleeves expand, and then it is installed. So it is quickly carried out by inserting into the pre-drilled holes and tightening with torque wrench. Also suitable for blind connection where access is available from one side only. And this is also recognized in the AIC Steel Construction Manual for use in all seismic design categories. So let us go to the jumbo hollow sections. Jumbo sections exceed standard sizes, allowing for greater structural applications and capabilities. They typically meet ASTM A500 and ASTM A1085 standards, ensuring quality and performance. Of course, I have given some sizes. square hollow section greater than 350 mm and up to 550 mm. Rectangular 600 mm by 300 mm up to 850 by 250 mm. Round hollow sections, outer diameter greater than 400 mm up to 700 mm, and wall thickness from 10 mm up to 25 mm. This is commonly used in construction, manufacture, and fabrication in large span structures, bridges, tall building, etc., due to their strength and aesthetic appeal. Their designs allows for efficient load distribution, making them suitable for large structures. I have shown some of them here. And one more interesting application. This is the MSG Sphere in Las Vegas. It was opened only recently. It is the largest spherical grid shell structure featuring 16K wraparound LED screen. Actually, outside, after construction, it has a LED screen and advanced audio technology. This 112-meter high and 157-meter wide dome uses 2,460 tons of hollow steel section supplied by Atlas tubes, and exterior LED trellis layer uses 191 mm outer diameter round hollow steel sections. And one more interesting thing is that it uses some of the 368 custom cast steel nodes created by Cast Connex. Actually, I will also discuss about this cast steel structures later in my presentation. And this structural design by Saurabh Associates and Walter P. Moore. Next, we will move on to the third section. There is high strength and ultra high strength structural steels. So typical sustained behavior. As you see, as strength increases, the ductility reduces. High strength structural steel generally have yield strengths of 460 to 700 MPa, and the ultra high strength structural steels have yield strengths of 700 MPa and above. And I have shown some of the examples of the steels that are available in other countries and also USA. They are produced commercially in many parts of the world at competitive prices, compared with conventional structural steels having yield strength of 235 to 355 MPa. These advanced steels provide higher strength to self weight ratio, often to 2 to 3 times higher. Their superior strength enables the design of lighter, more efficient structures, resulting in reduction in self-weight, reduced material, smaller foundations, easier transportation, easier fabrication and construction, lower CO2 emissions, more efficient office space, potential to reduce fire protection, and improved sustainability. I have shown two examples of structures built using high-strength structural steel. Zandhazen Railways Arch Bridge using 460 MPa steel, leading to total weight reduction of 30%. And another is Northern Spire two-span cable stayed bridge designed by Bureau Support. This high-strength steel design and execution. This is the source is SCAP 432 2020. That is a publication. So high strength steel, the Young's modulus of them requires essentially the same as that of conventional steel, thereby limiting improvements in stiffness and buckling resistance. However, their exceptional strength offers considerable opportunities for innovation in structural design. The widespread adoption of hollow steel section, high strength steel section, has the potential to significantly advance steel construction technology due to significant reduction in self-weight and associated savings in materials and time in construction of their support structures and foundation. And IS 2062 part 1, now it is published in part 1 and 2. Part 1 was published in 2025 and part 2 in 2026 only. It gives I have only listed the high strength steels here. In addition to the low ordinary strength steels, it also now lists up to 650 MPa grades. So I have shown the tensile strength, ultimate tensile strength and the percentage elongation. As you see, the percentage elongation reduces as the strength increases. And the draft IS 800, which I don't know will be released soon. It is under printing, I think. It has provisions for high strength seals also. So let us move to the fourth point, that is stainless steel. And I have shown an example of Gateway Arch. This is a 192-meter tall monument in St. Louis, Missouri, USA. This is clad in stainless steel and built in the form of catenary arch. It is the world's tallest arch. Another example of the stainless steel Brooklyn Museum of Art. It's a large stainless steel casting that float the glass above the plate beams and the tension trusses that stabilize the plate beams and provide vertical support for the glass. Actually, this was developed by pyramid structures, and that is given in design grade 27. And I designed the India's first stainless steel space frame roof. It is in Hisar, Haryana. This roof is 11 meters by 18 meters and supported by two circular RC columns of 500 mm diameter. The roof was modeled as space truss and analyzed with SAT-3 program. And it was fabricated and erected using mirror type joints in just 8 weeks. These stainless steel tubes of size 50 mm body and 2 mm thickness, and 50 mm body and 1.6 mm thickness, and 50 mm body and 4 mm thickness. And these are built connected with 16 mm stainless steel boards. And the joint is a mirror type joint. The tube wears SS304 grade and with the number 4 finish. Actually, this Mr. Sampath, he was the he developed this these stainless steel members and also the joints, and also constructed it in Haryana. So this is the typical stress strain curve for stainless steel and carbon steel for failure. This is from AIC design guide. So we don't have code for stainless steel yet. I don't know how this came. These are commonly used standard austenitic stainless steel S304 and S304L and contain 18 to 20% chromium and 8 to 11% nickel. And also S316 and S316L contain about 16 to 18% chromium, 10 to 14% nickel, and 2 to 3% molybdenum, which improves corrosion resistance. You see that in these things there is an L. So this L indicates low carbon version with a reduced risk of sensitization to intergranular corrosion in the heat affected zones of belts of these stainless steels. And duplex alloy is S3T205 is the most commonly used. It provides a significant increase in corrosion resistance. Other duplex alloy also present. And I am comparing 3 different grades of stainless steel, and the groups are austenitic, duplex, and ferric. And of course, these are the grades as per Eurocode, and these are the grades as per American codes and ASTM. Of course, as I have shown already, the chromium content differs, and nickel content also differs, and in some of them molybdenum is also there. And the ductility in some of them are very high, even compared to the steel. And as I already informed, there is no standard in India, but I have listed some of the current standards available in America and New Zealand, and also Eurocode. Of course, I believe this IS code for stainless steel is Vijay Venkatesh Kumar of NIT Surathkal is developing. This IS code. He is the student of Professor Arul Jayachandran for when he did his PhD. And of course, if you are using stainless steel, you also need stainless steel bolts. So I have listed some of the bolts as per ASTM, and I have shown these bolts also here. So next we will move on to the automated welding. And of course, if you are using stainless steel, you also need stainless steel bolts. So I have listed some. Sorry. Okay. Automated welding is key technology in modern steel construction, improving productivity, weld quality, safety, and consistency while reducing labor costs and fabrication time. Widely used in fabrication of bridges, buildings, and other structures. And there are three types of automated welding: mechanized welding, robotic welding, and adaptive welding. So I have shown one example of a welding machine. This also has 6-axis MIG welding rabo with arc tracking sensor, and you see that this trapezoidal plate girder with trapezoidal web is being welded using this automated welding system. So you actually, it is very difficult to manually weld such corrugated or trapezoidal or any other shape of webs using manual welding. So only with automated welding it is possible. And compared to flat steel web, the corrugated steel web has higher out-of-plane stiffness and shear buckling resistance. It also has reduced material, 30 to 60% lighter and labor cost, and higher 50% fatigue strength because of the stiffened webs. I forgot to tell, so if there is a slide and if there is a reference, that will give more details about the things I am discussing here. So future trends in automated welding are fully autonomous robotic welding cells, AI-driven adaptive welding systems, integration with building information modeling, robot coordinated welding, hybrid laser arc welding system, automated non-destructive evaluation integrated with welding, and sustainable welding processes with reduced energy consumption and emission. Next, we will move on to the curved steel. These are some of the examples of the curved members which are encountered in you may see in practice, like arch, bridge, and building with curved roof, and then stainless staircases with curved members. So this actually bender rollers receive the steel from the fabricator, or sometimes furnish it themselves, curve it, and then ship the curved steel back to the fabricator. So a bender roller is typically a specialty subcontractor of the steel fabricator. So you see the arch, bridge, and dome, and then curved roof. So this curving of steel members is a specialized fabrication process. To produce arches, curved girders, etc. The choice of the method depends on the required radius of curvature, member size, steel grade, cross-sectional shape, and accuracy requirements. And we curve these members with 8 different ways. I will give some of them in the next slides. The first is cold rolling. This is the most common and economical method. And in this, the member passes repeatedly through 3 or 4 powered rollers. You see these rollers here. The position of the central roll is gradually adjusted until the desired curvature is attained. The advantage is no heat is required, good dimensional accuracy, minimal effect on material properties, and economical for long members. So another thing is plate rolling. Steel plates are rolled into cylindrical or conical shapes before fabrication. A 3-roll or 4-roll plate bending machines gradually bends the plate into the required radius. The third type is heat bending. This is used for thick or heavy members. which requires localized heating. A narrow region is heated to approximately 600 to 900 degrees centigrade, after which the member is bent using hydraulic jacks or presses. As the heated zone cools, the steel contracts, producing the required curvature. Of course, as I told, it is suitable for large sections and can produce relatively tight radii. The problems are required skilled operators, may introduce residual stresses. Mechanical properties can be affected if temperature control is poor. Of course, we will discuss about the ways of curving hollow steel sections. Circular, square, or rectangular hollow steel sections can be generally curved using rotary draw bending, roll bending, and induction bending. To prevent local buckling or distortion, tubes may be filled with dry sand, low melting point alloy, or internal mandrels. The fourth type of bending is press bending. Hydraulic presses apply force. I am showing here, this is hydraulic press, which is at discrete points, it is applied to bend the member. It is suitable for thick plates, boss girders, heavy structural members. And another type of bending is induction bending. A narrow band of steel is heated. This is shown here. Using an induction coil while the member is pushed through a bending arm. It is very accurate, minimal distortion, tight radii possible, widely used in pipelines and tubular bridge members. And this is the concept, and you see how it is being bent here. Other members of curving members are stretch forming, is used for cold form members, flame line heating, and sometimes the member is not actually bent. Instead, it is fabricated from many straight segments or from curved plates that are welded together. Of course, when you are bending like that, and when you are using heat, it produces residual stresses and geometric imperfections. It may influence buckling resistance, fatigue performance, fracture behavior, and dimensional accuracy. For high-strength steel, tighter control is required because these steels generally have lower ductility and are more sensitive to cold working than conventional grades. Design specifications may require minimum bending radii and limits on induced strains. And once again, I have listed some of the design standards and guidance. AIC Design Guide 33, CDEC Design Guides, three guides are there. EN, that is Euro 10902, Euro Code 2, and American Welding Society D 1.1. So we will move on to the next one, diagrid systems. Of course, all of you know that First Organ was the inventor of this tall system. During 1960s, he found that beyond 10 stories, steel weight is increasing exponentially. Hence, he developed the signature tubular system for high-rise buildings and other variations like tube in tube, braced tube, bundle tube, etc. I am going to discuss only about the latest development in this tall building system. This is a diagrid system. Actually, in this system, they use perimeter diagonals for structural effectiveness, and which has lattice-like aesthetics. So I have shown a diagram and actual structures which use this diagrid system. One is a 46-story, 188-meter tall tower in New York, which was built in 2006. Kin, formerly 30th Street, Mary X, City of London, which was built in 2004, which has 41 floors and 180-meter tall. As you have seen, almost all the conventional vertical columns are eliminated. The diagonal members carry gravity loads as well as lateral forces due to that triangulated configurations. Compared with conventional frame tubular structures without diagonals, they are much more effective in minimizing shear deformation. It is because they carry shear by axial action of the diagonal members, while conventional tubular structures carry shear by the bending of the vertical columns and horizontal spandrels. You know that bend tension and compression are better than bending members. And I have shown the tubular node for the Gaherkin London structure, and you can refer these references for more details. They provide both bending and shear rigidity. Unlike outrigger structures, they do not need high shear rigidity cores because the shear can be carried by the diagrids located on the perimeter. Super tall buildings with a diagrid system can be further strengthened and stiffened by engaging the core, generating a system similar to tube in tube. The optimum angle for the diagonals were found to be 63 degrees up to 40 to 50 stories and 69 degrees for up to 60 to 100 stories. I have shown some more examples. The outside facades are different in this, but these are also diagrid systems. Due to the facade aesthetics, they look fluid and irregular and different from the explicit and pristine features of the steel diagonals. And another exotic application of this diagrid structure is the CCTV tower in China, which was constructed in 2008 during the Olympic Games. It is an example of an innovative diagrid system that improves structural performance and produces exotic form. But I don't like this structure because of the two cantilevers which are connecting these two towers. Another exotic diagrid structure, I found it to be very different. This was designed by late architect Zaha Hadid, and she is very popular for producing very different looking structures and especially curved structures. This is a 160-meter tall with 40 stories. This is Morpheus Hotel at the city of dreams in Macau, China. So you see in this image, this is the dynamic portion of the diagrid. So this portion is expanded here and shown. And in addition to the ordinary diagrid, we also have hexagrid system. It's a new system that consists of multiple hexagonal grids. You see, they are hexagonal at the exterior perimeter surfaces of the building. There are also other systems which can be used for lateral load resistance. They include space frames, super frames, and exoskeleton. They have been used occasionally in tall buildings. So this one example of this is here. This is a Bank of China tower built in 1980, and the architect is IM Pai of Hong Kong. This building is in Hong Kong. So let us go to the eighth topic. Pre-qualified moment connections. Actually, pre-qualified moment connections were developed to provide reliable, ductile, and economically practical beam-to-column connections for steel moment-resistant frames, particularly in regions of high seismicity. Actually, why they were developed? In America and Japan, they found that their welded steel moment connections are very good. But during the 1994 Northridge earthquake in California and during 1985 Kobe earthquake in Japan, there were unexpected vulnerabilities in the steel welded steel moment connection. So ASC 341 established a series of requirements to permit their use. That is pre-qualified use. Starting with AAC 358 2010. Now the current thing is 2022. Materials design, detailing, fabrication, and inspection of seven connections for special and intermediate steel mutual movement frames were referenced by AIC 341. These pre-qualified movement connections have been thoroughly tested and evaluated by an AASC sponsored standard body for their expected performance and during big earthquakes. Of course, you have to note that in any earthquake resistant connection, adequate performance may include some amount of damage. Actually, the current version AAC 358.22 gives 12 types of pre-qualified moment connections. Here, SMF and IMF refer to special moment frames and intermediate moment frames. And from between 2009 and 2022, 6 pre-qualified proprietary connections were added to the AAC 358. I listed these connections here, and I will only discuss about a few because of the limited time. Reduced beam section, bolted and unstiffened extended end plate, bolted stiffened extended end plate, bolted flange plate, welded unreinforced flange welded web, cast bolted bracket. I will discuss about this. Connex Tech and Con XL, side plate, Simpson strong frame, double T, slotted web, Durafuse frames. Actually, some of them are patented. As per 2022 edition, only Con XL, side plate, and Simpson strong frame and Durafuse frames are proprietary, and all others you can use it. And the design methods are given in IASC 358.22. I will explain only one or two, a few of them in the next slides. This is the simplest thing. The main aim in all the systems is that the connection should be safe during earthquakes, and hence the plastic hinge should form in the beams. So that is the main aim for all these sections. So in this system, portions of the beam flanges are trimmed. You see here in a curvular fashion in the region adjacent to the beam column connection. Yielding and hitch formation are to occur within the reduced section of the beam, and beam web is connected to the column flange using CJP groove weld extending beyond weld access holes. Of course, for the limitations of all these connections, see the AAC code 358. So again, the same thing. Of course, I have shown only curved, but it is also possible to have straight, tapered, or even having holes, because the main aim is to weaken the section where the plastic hinges will form. Of course, I have given the radius also how to trim this section. So 2 and 3 are bolted unstiffened extended end plate connections. So I have shown this in actual structure, and the concept is shown here. It can be 4 bolt unstiffened, 4 bolt stiffened, or 8 bolt stiffened. Continuity plates, actually here, shown here, are often required between column flanges to transfer beam flange forces through the connection and to stiffen the column web and flanges. So these are different extended plate connections as per the AIC Design Guide 39. And 3 types of end plate moment connection behavior. This is a thin end plate, so which will result in prying action. First limit state is end plate yielding, followed by bolt rupture and prying action. And in thick end plates, limit state is bolt rupture without prying action. And in plastic hinging behavior, limit state is plastic hinging of the beam. Next one is bolted flange plate moment connection. Once again, plastic is intended to occur in the beam near the here. The flange plates and web shear plate are sharp welded using CJP groove welds to the column flanges and bolted high strength bolts to the beam flanges and web respectively at the site. So this is once again an interesting system. Cast bolted bracket connection. This was previously a patented connection. You see here two different series, W series and B series. One is here welded and other is bolted. The cast high-strength steel bracket is fastened to each beam flange in the shop and bolted to the column flange in the field. The bracket is proportioned to develop the probable maximum moment of the connected beam. Yielding and plastic hinge formations are made to occur mainly in the beam at the end of the bracket here away from the column face. In all the things, the plastic hinge will form here or required to form here. These are actual examples of the Kaiser cast bolted bracket moment connection. Kaiser is a company. It eliminates all field welding and reduces costs associated with fabrication and inspection. To provide erection tolerance, the bracket column holes are vertically slotted and the column bolt holes are slightly oversized. This is a patented connection. It looks complicated, but once you give the forces and other details, they will give the plates and other things, and they will fabricate it. So it uses an interconnected plate to connect beams to column. It features a physical separation or gap between the face of the column flange and the end of the beams. Both field welded and field bolted options are available. Beams may be rolled, built up white flange or hollow steel.
Please mute yourself.
So here
Others,
I have
please
said
mute
white
yourself.
So here I have shown a hollow steel section and three different situations. One is one-sided white flange, two-sided white flange beam and column connection. That is both the beams and columns are white flange. But here the column is hollow steel section, but the beam is white flange section. And it shows the different configurations of the side plate connection. Only field welds and no groove welds. This shows the actual side plate connection at the construction site. And another patented connection is Connex Tech's company. It's Con XL and Con XR moment connections. This is also looks slightly complicated. This patented system permits full strength, fully restrained connection of white flange beams to concrete filled 400 mm square hollow sections or built up box columns using high strength field bolted collar assembly. These beams are shop welded to forged flanges. So these are forged flanges and web fittings. This field bolted together either forged or cast steel column fittings that are shop welded to the columns. You will see it here, and these are the two different Con XR200 system and Con XL 400 system. So you see this special connection details, and this beam is forced into this thing. When it clicks, the joint is formed. So another approach to have is replaceable shear fuse connection. This connection has a steel fuse plate at the beam bottom flange here that limits the amount of force that can develop at the face of the column. The shear yielding mechanism in the fuse is not susceptible to local buckling, so large rotations can be accommodated without strength degradation. These show some of the details. So Richards and others, they developed this system, and based on that, that AIC code has another system. It is Duraff push moment connection. This is also a patent connection. The beam flanges are attached to the external continuity plates via top plate and fuse plate. The beam flanges and external continuity plates have standard holes, while the top plates and fuse plate have oversized holes. The fuse plate is proportioned such that shear yielding occurs in it when connection is subjected to severe earthquake loads. So this shows a one-sided Dura-fuse connection with wide flanged beam and hollow steel column. Actually, the fuse plate can be removed and replaced following an severe earthquake, because during earthquake the bottom plate will be damaged. The top plates, these top plates experience minimal yielding and need not require any repair. The components are proportioned in such a way that beam remains essentially elastic. So one more thing I told you about this cast connections. I have shown one more example, and it is available in different sizes. And actual, it is you see the size of the member, which is so big, and it is a cast connection. Connex connection, that is a company. Cast Connex is the company. More details you can see the website of Cast Connex. So this cast connection, they are high strength steel connector for round hollow section brace members in a concentrically braced frame. Single cast piece with a solid circular end that is sharp welded to round HSS braces. Circular section gradually tapers to two adjacent plates that accommodated a bolted double shear connection, which you saw in the previous slide. Connectors are attached at both ends of the round hollow steel brace and are field bolted or welded to a gusset plate. It provides more compact field bolted connection with 50% less bolts, less fabrication and field work. And it eliminates need for typical welded details such as started hollow steel section and net section reinforcement, which are vulnerable during earthquakes. Designed to develop the probable tensile capacity of the bracing member and has been rigorously tested. And we will go on to the ninth section. I hope I am on time. Hope Mr. and Ghosh will give me enough time.
Yes, sir.
This is steel plate shear wall. These are similar to the concrete shear walls, but they are very well economical. This is a planar SPSW is abbreviation for steel plate shear walls. This Canem headquarters in the USA. You can see more details about it in the September 2001 issue of Modern Steel Construction. The advantages are less structural wall thickness than concrete shear walls, steel savings of up to 50% compared with moment resistant frames, and compared with the RC shear walls results in reduced foundation cost, reduces construction time, fast to erect and no curing period as in RC walls, have excellent post buckling capacity. The design is included in AIC. SPW ductility is superior to braced frame, and moment resistant frame can survive up to 4 to 5% drift without experiencing significant damage. At least 2 buildings with such walls experienced significant earthquakes and survived with insignificant structural damage. So AIC 341 allows the analysis of each web plate to be modeled as a series of inclined pin-ended studs or strips oriented at an angle of alpha. You can refer to this code for the design equations. And Professor Bruno in USA, he also worked on perforated steel plate shear walls. These hot rolled steel plates are often thicker or stronger than those required as per design for the webs of SPW in low, medium rise buildings. This will impose large design demands on surrounding vertical or horizontal boundary elements. These are the vertical and horizontal boundary elements. Several solutions are available: use of light gauge cold rolled steel, use of low yield steel sheets, and use of perforated steel plate shear walls. The holes also allow for the utilities to pass through. The holes may be at the corners or in the center also. Another interesting development is this self-centering SPSW, using the pre-stressing cables. This post-tensioning, this technique enhances the wall's ability to return its original position after deformation, minimizing residual displacement. It can effectively withstand cyclic loading, demonstrating resilience and stability, are increasingly used in seismic design due to their ability to absorb and dissipate energy, making them suitable for large earthquake-prone areas. So we will go to the 10th section, that is composite speed core walls. This is a very interesting development. This system, also known as speed core system, it is a non-proprietary innovative system. That means you can also use it without paying any royalty. It is a revolutionary system of the composite structural steel framing system. It consists of two steel plates that are held in position by cross ties. You can see these cross ties. The outer steel plates act as permanent formwork and reinforcing steel for the inner concrete core. And after assembly, the concrete is poured inside. The outer plates are tied together using round tie bars spaced horizontally and vertically, which can be welded to the steel plate in the factory or secured with a double nut configuration. Usually, after I told, fabricated in shop and shipped to the job site, where they are assembled and erected to their final core configuration. In addition to this tie bars, we are also having shear studs for composite action between the inner concrete and the outer steel plates. So this is an assembly of the speed core two-story units. Once they are made, they are the concrete is poured. That is consolidating concrete is placed between them. The concrete combined with the steel plates provide the ultimate strength and stiffness for the core wall assembly as a composite section. Once the concrete placed inside the plates is inside the plate is cured properly, it acts compositively with the speed core components of plates, cross ties, and shear connections. Actually, interestingly, this was developed by an Indian Professor Verma, who is working in USA, and Bharadwaj was a student. The first application of this system was in Rainier Square Tower in Seattle. This is a 58-story, 260-meter tall, mixed-use Rainier Square Tower, and it was opened in 2021. Actually, it is only a schematic. I will show in the next slide the actual structure. The use of speed core cut 10 months of 32 months schedule, erected 43% faster with 4 floors completed weekly. It consisted 8 concrete-filled steel box columns at the core corners, each one the thickness of core wall. These blocks, ranging from 530 mm to 1140 mm in thickness, formed with two 4.27 mm high. I think it is not thickness, it is height. High steel plates varying in thickness from 12.5 mm to 19 mm and tied together with 25 mm diameter steel rods placed between 300 mm centers, both horizontally vertically, and they were craned into place between each set of columns. So this shows the erection of this building, and extensive testing was carried out at Purdue University by Professor Verma. It demonstrated that it performed safely at 2-hour fire rating on a 300 mm thick wall without any added fireproofing, a strategy that MKA, that is a construction company, now implementing in their new projects. Of course, I just wanted to project a slide of this buckling restraint brace because the concept was originally developed by Dr. B. N. Sridhara of Bangalore, India, and first introduced by Tegita et al. In 1976, and deals with the buckling problem of tension and compression steel bases. So several other researchers also were studied this problem and developed different configurations such as circular core and crosswire core and linear core braces. Some of them are patented. Between the metal joint and the concrete, a suitable coating is placed, which allows the joint to slide relative to the concrete. This method of construction allows the system to accept axial, compressive, and tensile forces, which are received only by the metal link. Only this. Link located at core construction due to slippage. The outer mantle of the concrete is intended to limit the free bending length of the metal joint. They rely on ductility and generally must be replaced after any major earthquake because they are only bolted to the structure. Now we'll next go to the 11th one, painting system to reduce corrosion. So primary methods of corrosion control are material selection, inorganic or organic metal coating, hot dip galvanizing, use of inhibitors, controlling the electrode potential, detailing to reduce corrosion, use of weathering steel. Now we will only discuss about the one of the coating systems in this presentation. Chapter 15 of IS 800 provides details like desired life of coating system in different environments and specification for different coating systems. It also gives 3 coat heavy duty anti-corrosion system is required, and the top coat acts as the first line of defense. So the conventional top coats like acrylic urethane, which has limited UV resistance, degrades under UV exposure, that is due to sunlight, gradually thinning, micro-cracking, and losing binder integrity. Once the top coat erodes, moisture, oxygen, and chlorides rapidly break down and the underlying epoxy barrier, initiating localized keep. Hence, a new overcoating, that is the third layer of coating, called FEVE top coat has been developed in USA, and it is discussed now. This is FEVE is a short form of fluoroethylene vinyl ether. It represents one of the most significant advances in high performance corrosion protection for structural steels, where traditional polyurethane top coats degrade after 10 to 15 years. FEVE coatings extend maintenance free service up to 30 to 60 years. It's a 100% fluoropolymer alternating copolymer consisting of fluoroethylene units and vinyl ether units, which provides solubility, adhesion, and hydroxyl function groups. When mixed with a cross linker, typically in aliphatic polyisocyanates, it forms a thermostat cross-linked matrix via chemical bonding. It's a chemical process. These are the advantages of this top coat. It has more than 30 years of top coat life, can be sprayed, applied directly on the shop or field, and cured at room temperature. Standard painting equipment application methods only are required. Has superior gloss and color retention, maintains 70 to 90% gloss retention after 10 to 20 years, up to 10 to 20 years. And then provides good corrosion resistance, has superior resistance to chalking, resistant to airborne chemicals and acid rain, resistant to cleaning solvents used to remove graffiti. Of course, graffiti is seen in many US cities. Formulated to meet all air quality regulations. While it may have higher raw material price, the top coat itself accounts for only 5 to 10% of the initial application costs, because the majority of surface costs are due to surface preparation, blast cleaning, staging, and labor. I have given 2 examples of these structures. Both are bridge structures using this top coat. One is the bridge in Japan and the other bridge is in USA. This was restored in 2013 with FEV resistance. Its former coating had crumbled to chalking, peeling, and corrosion of the steel surface underneath. The coating system was applied at site because it's a existing structure and cured under ambient temperature shortly after spraying. Now we will go to strengthening and repair of structures. There is a need to enhance strength and service life of structures, mainly due to degradation of steel with time, due to corrosion and other things, or increase its service loads. Traditional techniques such as steel plate reinforcement by welding or bolting can be time consuming and complex. Smart materials such as shape memory alloys have also been recently explored, and use of external precessing cables. So, of course, these external precessing cables I discussed in a previous slide. The recent emergence of VAM in construction offers great potential for strengthening and repair. Significant capacity gains can be attained through the addition of relatively little VAM material, but in optimum locations such as highly stressed regions of new structures or damaged critical regions of existing structures. Let us see how. So Garner et al. In their paper describe about this strengthening. So you can strengthen the whole thing by having extra material here or only extra material where the things are corroded, and also extra material, of course it keeps on increasing at the midsection but reducing at the ends. All these things are possible. It disproportionately high increases in axial capacity of between 17 to 54% for the relatively modest increase of masses between 2 to 26%. If you increase the mass by 2 to 26%, the capacity increases by 17 to 54%. Demonstrating the substantial benefits in terms of enhanced structural efficiency and material savings. Of course, VAM, I discussed it initially. I will just discuss about the cold spray additive manufacturing. It is a solid state material deposition process originally introduced in the 1980s itself for surface coatings. By using heated compressed gas to accelerate metallic or composite powders to supersonic speeds, creates impact-induced dense bonds via mechanical interlocking and metallurgical adhesion. Because the feedstock remains solid throughout the process and relies on kinetic energy rather than melting, cold spray eliminates thermal defects typical to high temperature processes such as oxidation, phase transformation, and severe residual thermal stresses. Successful cold spray buildup requires feedstock particles to exceed critical impact velocity across two distinct stages. In the first stage, incoming particles bond directly to the substrate. In the second, subsequent particles bond to previously deposited layers. Where the powder and substrate share the same composition, the critical velocities for both stages are essentially identical. I will show a slide which shows the CSAM process and how it is bonding and the advantages and the typical applications. So this shows the comparison of VAM and CSAM. Deposition state, it is molten state, it is solid state, kinetic plastic deformation, heat affected zone, significant heat affected zone, but zero heat affected zone because it is not heated. In situ stress relief often requires interpass temperature monitoring, but requires no heat treatment to prevent distortion through post-spray pinning or annealing may be needed to recover ductility. So we will pass on to the 13th, sustainability and reuse. Three great things we have to remember in sustainability is reduce, recycle, and reuse. Reduce is by using high-strength steel, hollow steel sections, optimal configurations, etc. Recycle, of course, steel is the most recyclable material. 80 to 88% of steel is recycled, especially in electric arc furnace. And we will only discuss about reuse here. Of course, in order to reuse, you have to properly design the structure so that it can the beams or columns can be dismantled and used in a new structure. So, as already I have told, it involves designing, constructing, operating, and decommissioning structures in a manner that minimizes environmental impact while maximizing economic and social benefit throughout their life cycle. Steel is one of the most sustainable construction materials because it can be recycled indefinitely without significant loss of mechanical properties. Modern steel production increasingly uses electric arc furnace, renewable energy, and scrap steel sustainably substantially reducing carbon emissions compared with traditional blast furnace production. The use of high-strength steel, weathering steel, modular construction, building information modeling, life cycle assessment, and environmental product declarations further enhances the sustainability of steel structures. They offer high strength to weight ratio, reducing material consumption and foundation sizes, offsite fabrication, minimizing construction waste and improving quality, rapid construction, reducing energy use and site disturbance, high durability with appropriate corrosion protection, adaptability to future modification and expansion, compatibility with circular economy principles through reuse and recycling. So it is uniquely suited for direct reuse, not like concrete where the steel rods have to be separated and it has to be processed in factory, etc. The steel members can be easily dismantled and incorporated in new structure with minimal reprocessing, provided it has been designed for reuse. Unlike recycling, reuse preserves the embodied energy and carbon already invested in manufacturing, resulting in much greater environmental benefits. Successful reuse requires careful deconstruction rather than demolition, inspection for corrosion, fatigue, reformation, and damage, verification of material properties and weldability, assessment of residual strength and serviceability, appropriate redesign and connection modification to satisfy current design codes. Of course, beam columns, trusses, all the things can be reused in structural new steel structures. I have listed some of the benefits and challenges. Significant of I am not going to read these benefits. Challenges are limited documentation of existing structures, variability in material properties of old steel, inspection and certification requirements, transportation, storage, logistics. Because if you are using it in one place and reusing it in another place, it requires some storage logistics. Lack of standardized design guidance and market infrastructure. I am showing there are four already several examples of reuse. I have shown four examples of buildings where they are reused. It is from this paper, and this shows CO2 emission saved due to reuse in tons. In one building, it is 1,000 tons, and primary steel material saved due to reuse. And these are all recent one from 2019 to 2022, and one Sloan Square house is done and it is underway. So these shows the reclaimed steel ready for reuse. Final, we have come to the final thing. I will go fast in here also. This is artificial intelligence and related topics. Because artificial intelligence is a buzzword which is used everywhere, I just wanted to add this also. Artificial intelligence is transforming the steel construction industry by enhancing the planning, design, fabrication, construction, inspection, and maintenance of steel structures. It enables computers perform tasks that traditionally require human intelligence, including learning from data, recognizing patterns, making decisions, and solving complex engineering problems. Combined with digital technologies such as BAM, Internet of Things, robotics, digital twins, drones, and LIDAR, AI is paving the way for smarter, safer, and more sustainable steel construction. Of course, these are the major AI technologies you might have known: machine learning, deep learning, computer vision. Actually, this is very good because AI-based image processing for automated inspection of welds, corrosion, cracks, bolts, and fabrication quality using cameras and drones. Natural language processing, generative AI. This assisted engineers in drafting reports, generating design alternatives, writing specifications, and summarizing technical documents. After the introduction of ChatGPT and Gemini and other platforms. Engineers are using this generative AI extensively. And expert system, these are knowledge-based systems that emulate the decision-making ability of experienced structural engineers. So AI could be applied throughout the life cycle of steel structures. Structural design optimization, you know already about this. Building information modeling, of course, these are slightly expensive systems. This is the integration of AI with BAM. And connection design, fabrication automation. So we also saw welding, but you can also robotic cutting, drilling, welding, and assembly using AI for improved precision and productivity. Quality control, construction planning, structural health monitoring, and digital twins. In this digital twins, virtual replicas of steel structures are continuously updated with sensor data to enable real-time performance assessment and life cycle management. Some AI tools in steel construction are listed here. For connection design and finite element optimization, Idea Statica, Path WAA, and quantity takeoff estimation and material extraction, steel flow, sketchdeck.aa, detailing BAM fabrication automation, Tekla structures AA and open API extension, SDS2 AA plugins, and drawing review, quality assurance and quality control and constructability, Hellonic and structure AA. These are the tools. Some of them, many of them are you have to buy and use it. And future trends in AR, future of AI will increasingly rely on intelligent digital ecosystem combining AI, BAM, digital twins, robotics, Internet of Things, cloud computing, and advanced sensing technologies. These innovations will support autonomous construction, real-time structural monitoring, optimized maintenance, and sustainable infrastructure management. AI will increasingly function as an engineering assistant, enabling structural engineers to make faster, better informed decisions while maintaining safety, code compliance, and engineering judgment. While AI cannot replace the experience and judgment of structural engineers, it serves as a powerful decision support tool that enhances efficiency, innovation, quality, and sustainability across the entire life cycle of steel structures. And I just also want to show some smart building technologies and adaptive materials. Disaster resilient structures often incorporate smart building technologies such as sensors, monitoring system, and automated response system to detect and respond to potential disaster. Some structures incorporate adaptive materials that can respond to changing environmental conditions, such as shape memory alloys. I have listed some of the shape memory alloys, and their super elastic and shape memory effects make them highly beneficial for earthquake resistant and durable RC and steel structures also. Finally, I just wanted to show one interesting structure. This is world largest hybrid tensegrity bridge at Queensland, Australia. You see that the advantages this will have continuous tension members and discontinuous compression members. In that way, you all know that tension is the most better system than compression, because in compression we have buckling. So it is this complex cabling system comprises 80 main galvanized helical strand cables and 252 tensegrity cables that are made from super duplex central steel. So finally, in summary, shifting from standard carbon steel to high steel, stainless steel, and localized VAM, 3D printing can minimize dead weight and maximize durability. And systematic shifts, transitioning to high performance rapid assembly systems like speed core, diagonal system, and seal plate shear walls can optimize lateral resistance and reduce construction time. And life cycle management, advanced corrosion resistant coatings, and pioneering repair techniques like cold spray can protect and extend infrastructure lifespans. And finally, the digital green twin, AI-driven design automation with a strict circular economy framework focused on tracking and direct reuse of structural steel elements may result in a sustainability. So final conclusions, the road ahead for INSDAG is the next era of steel construction is not defined by producing more volume, but by embedding higher intelligence, speed and circularity into every single ton of steel construction and pioneering the codes. Technologies like VAM repair, speed core and steel structural reuse represent the immediate next frontier for IS 800 revisions and Indian standardization and bridging the gap. Successfully deploying these 14 things which I discussed requires continuous deep collaboration between steel manufacturers, designers, and academic researchers. The ultimate goal is building a safer, faster, and genuinely net zero carbon national infrastructure for India. Thank you very much.
Thank you, sir. It was a fantastic presentation. In fact, the contents, you have 14 chapters. Each and every chapter can be a training program. So we can have 14 training programs because of the importance of those chapters. Thank you so much, sir. Before that, please go through the chat box. There are some technical questions which, sir, you have to reply. So please go through the chat box, sir.
Actually, I am getting one meeting is over like that.
Sir,
Do you hear me?
yes, sir.
Okay.
Can't you access the chat box, sir?
Mr. Ghosh, I will suggest you please select some of the questions and you can read it out to Dr. Subramaniam.
Okay, okay.
Instead
sir.
of his going through entire question,
Uh-huh.
please select one or three or four important questions and let Dr. Subramaniam respond.
Okay, sir. I'll try.
Actually, I can read
there is-
one question. Any
sir?
blocks here to cover plate in the side plate connection?
Yeah, that is a
Of course,
question.
all the design provisions in the codes have to be covered, and in the ASC code, the design methods are provided. So it actually all these patented connection and other connections have been thoroughly tested and then only recommended. And if you go through this code, you will know what are the design provisions which you have to cover.
Okay, sir. Okay. Sir, there is another question. Are the steel shear walls hollow like speed core walls?
Actually, in the I only covered only steel plate shear wall. There can also be composite shear wall. So the what I presented is only plain. You can have a composite shear walls also.
Okay. Sir, another question. How the splice is done at site for speed core wall system? How the splice is done?
Yeah. Actually, most of the things are constructed in the factory. One big unit is transported by lorries and then kept at the site. One by one, it is added, and then they by side plates they're welded to the previous section.
Okay, okay.
Of course, I have listed some of the papers. If you browse speed core section, you will get those papers and it will give more details.
Okay, okay. That's a good idea. Sir, I think there are no more technical questions. We will be sharing the presentation to all the participants.
Thank you very
So,
much.
yes, sir, because it is quite heavily loaded and we require to go through it at least a number of times.
Thank you.
Thank you very much. And participants, before we leave today's program, we have a list of training programs listed. I will now ask Rishabh, our teammate, to give you the details of the training programs. Over to Rishabh.
Thank you, sir. Am I audible?
Rishabh,
Yes.
just a minute. Before you get into your part of the this thing talking, let me thank Dr. Subramaniam, sir. We are really grateful. You can see the
Thank you,
number
sir.
of messages and compliments that are coming in the chat boxes, and we are really grateful, sir, for this beautiful presentation and some of
You're
these
welcome.
ideas that you have thrown for INSTAG. We will certainly try to work on them. May not be in all areas, but in few areas certainly try to work on them, take your guidance and report also your also our activity to you, so that you'll feel happy that INSTAG, even though it's just a small institute, but it is trying its best to uh, bring in that awareness of what you call this advanced method of construction technology by using steel in the country. That we are certainly trying to do. So Dr. Subbarao, Dr. Harshavardhan Subbarao,
He is also there in the line.
he is also
Yes.
Namaste, Dr. Subbarao. He big name in consultancy here in the country. He is the head of this Constuma, and he has done his PhD in Imperial College of London. You are mentioning few times some time back. He is our executive council member, and Dr. L.M. Gupta, you know him, sir. So I am really grateful to all of you, sir. You have come, and Mr. Abhijit Kumar, ED Marketing, also is in attendance, and Dr. Kausab Dasgupta, also from IIT Guwahati, also he is there. My thanks to you, Dr. Dasgupta, if you are still there. So these are the people, it's a great opportunity for us, sir. I look forward to your blessing, your good wishes, your support, your guidance for this tiny institute. All of you, sir.
He's always
Thank,
there.
thank you. And Rishabh, you can continue.
So before that, if Dr. Subbarao wants to
Sir. Sir, you want to tell
anything.
something?
Subramanian sir, this has just been such a masterful presentation.
Thank
So
you.
much to learn, so much you have to share with us. We look forward to continuously learning from a guru like you.
Oh, thank you very much.
Absolutely magical. 1.5,
Actually,
1 hour, 45 minutes of pure magic, sir. To
Thank you.
give us
Actually,
so many thoughts for our mind. Thank you so much.
I know your father very well.
I know, sir. Everybody knows my father, and some even know my grandfather. So I've been in many events where this happens. So you'll be happy to note that the T.N. Subbarao chair is instituted in IIT Chennai. We have a chair in his name at IIT Chennai.
Who is the professor? Is there now?
Sir, I
Who
didn't
is the
hear you, sir.
professor?
It was set up when Professor Koshi and Mayor Prasad and all, they set it up at that time.
Oh, I think Mayor
And
Prasad
it
is the professor chair.
It was. Then Professor Koshi, I think. And
Okay.
it's more on construction, not on steel. I am a
Yeah,
steel man. I have a PhD from Imperial College in Steel, as you know. And currently, sir, with all your blessings, I am serving as the first Indian to be elected as president of the International Association of Bridge and Structural Engineering in Zurich. So I'm first Indian ever in 100 years to be elected to that body.
Excellent. Congratulations.
So I will live up to your expectations, I hope, sir.
Thank you, sir. Dr. L.M. Gupta is also on the line. Sir, do you have any word?
Thank you very much, sir. Sir, thank you. Thanks a lot. And you have given a roadmap for next 30 years for your country. I think so. One slide can at least produce 10 PhD. So there are there are a lot of research work the accommodation can take and make our India strong still through this platform. Thank you very much, sir, for your presentation.
Thank you, Professor Gupta. Actually, many people may not know Professor Gupta's PhD guide was my external examiner for my PhD. So he is M.M. Bosole. So recently I got connected with him through him. Thank you very much.
Yeah, thank you, sir. Thank you.
Thank you, sir. Let us now schedule our next training programs. I would request Rishabh to now take over. Rishabh, please.
Thank you, sir. Am I audible?
Yes, yes.
Okay. So can you kindly confirm that whether my slides
Yes. Everything is okay. You can continue.
Thank you, sir, for your wonderful lectures and for sharing your valuable insights with us on the occasion of Foundation Day of INSDAG. And also, I would like to sincerely thank all the participants for joining us and making this session a meaningful and engaging one. So now, as you are already aware, INSDAG organizes a number of online and offline programs throughout the year, covering a wide range of topics related to steel structures and constructions. At present, 3 exciting online training programs are lined up, focusing on practical, contemporary, and industry-relevant topics. The first one, which is just scheduled on tomorrow, is on steel connection design with software tools with Idea Statica. So in this program, the practical aspects of bolted and welded connection design as per Indian standards will be covered, along with the software applications with Idea Statica and real-world fabrications and detailing challenges will be covered. The next one is the structural design and testing of steel towers with ACRC. It is a certificate course of 3 days, which is scheduled on September 28, 29, and 30, 2026. In this program, will provide a comprehensive coverage of steel tower design and testing, including the structural analysis, connections, foundation design, software applications, and full-scale testing of steel towers. The next one is the sustainability parameters of steel structures, LCA, and green building tools with one-click LCA, which is scheduled on 5th October 2026, which is a one-day training program. In this program, life cycle assessment, embodied carbon, and material efficiency in sustainable steel construction will be explored. Participants will also get a practical exposure to one-click LCA, including a live demonstration and hands-on trial on the tool. So I would therefore encourage all of you to make the most of these opportunities and benefit of the knowledge and experience of leading experts from the academia as well as the industry. And we look forward for your active participants and continued association with INSDAG. Thank you once again, and we hope to see you in these upcoming training programs. Thank you, everyone.
Thank you, Rishabh, and thank you, Dr. Subramaniam, and all the participants. Just to inform that we will be sending the recorded version in your email from tomorrow. With this, we end our Foundation Day program, and we will now concentrate on the training programs, which is organized each and every month. Thank you, everybody. Thank you, Dr. Subramaniam. Thank you,
Thank you,
sir.
sir.
Thank you, Ghosh Saab. Thank you
Yes,
very
sir.
much. And thank you, of course, Mishra ji and
Thank you, sir.
the Guru. We close this evening with a note to Guru on steel. Thank you. Thank you, all of you all for being here. Our Guru has spoken today and we have learned a lot. On that note.
Yes, sir. Yes, sir. Okay, sir. With this, we are now moving out of this program. Thanks a lot.
Thank you very much.